Okay, a quick overview on how we factor a perfect square trinomial. So a perfect square trinomial is one that happens to be in the form some perfect square at the start, some perfect square at the end, and in the middle is 2 times the square root of both of those perfect squares. And if I happen to see something in that form, it's really easy to factor. I just take the square root of the first, the square root of the last, quantity squared, which of course we know means a plus b times a plus b, right? This also works if the middle sign is negative, but I still have a perfect square at the start, a perfect square at the end, and double the square root in the middle. Then the only thing that's different is that when I factor it, I take the square root of the first, subtract the square root of the second, which of course means a minus b and a minus b. Okay, so let me give you an example of a perfect square trinomial. Let's say we have 4x squared plus 12x plus 9. The first thing I need to do is I need to recognize that, hey, look, this is a perfect square and so is this. So I recognize first of all that they're perfect squares. But the next thing I have to do if I want to use this method is I also have to look at the middle number, and I have to see if that 12x is the square root of the 2 perfect squares on the outside. So the square root of 4 is 2, the square root of 9 is 3, so 2 times 3 is equal to 6, and in order to match the pattern, the middle term has to be 2 times the product of the outside term square root. So 2 times 3 gave me 6, so the middle term has to be a 12 for this to be a perfect square trinomial. So 12 is 2 times 6. So yes, this is a perfect square trinomial. Okay? And once I have a perfect square trinomial, the hardest part is recognizing it. The easiest part is factoring it. Take the square root of the first term, put it at the start of the bracket, 2x. Square root of the last, put it at the end of the bracket, 3. And look at the middle sign here and make sure the whole thing is squared. Okay, and let's just check to make sure that that's true, that I'm not just giving you a story here. So let's check that 2x plus 3 quantity squared will give us our original question. And you can remember it by the song or by the poem, which is square the first, square the last, double the product, it's a blast. Or by remembering that 2x plus 3 squared actually means 2x plus 3 times 2x plus 3. And you can FOIL that out. I'm going to do it using the poem. So I square the first, which is 4x squared, square the last, which is 9, and I'm going to double the product. So 3 times 2 is 6 times 2 is 12x, and it matches my original question. So that makes me happy. So again, the hardest part is recognizing whether it's a perfect square trinomial. The easiest part is doing the factoring. Let's do another example just to make sure we're all on the same page here. So let's say you were given something like 25m squared and plus, or minus, let's do minus this time, 50m plus, let's do mn plus n squared. So again, if I suspect that this might be a perfect square trinomial, I have to check first. So I take a look at the start, that's a perfect square. I take a look at the end, that's a perfect square. That's the number 1, n squared. So both of those are perfect squares. The next thing I have to do is check the middle and see if the middle is double the square root of the 2 outside terms. So let's check out negative 50. So the square root of 25 is 5. Let's write this in pen. So the square root of 25, of course, is 5. And the square root of 1, which is this number here, square root of 1, of course, is 1. And if I multiply 5 times 1, I'm going to get 5. And double 5 is equal to 10. So this right here is not a perfect square trinomial the way it's written. So we could not do this method if we were given this type of factoring. Okay, let's change it into what would make it a perfect square trinomial. So I'm going to erase out the 50, and we're going to put a number in there that makes it a perfect square trinomial. So it's got to be the square root of the first, the square root of the last doubled. So it's got to be double 5, which is going to be 10 mn. All right, so now it's a perfect square trinomial. So now to factor it, I take the square root of the first, square root of the last, and the middle sign, and don't forget to square that. Okay, you can always double check, square the first, square the last, double the product, it's a blast. And you got it.